BERT calculates where the answer to our question is within our text by creating start vectors and end vectors. It then takes these start and end vectors and takes the dot product between these and the final embedding for each token. This output then runs through a softmax function to give a probability score. The word with the highest probability is considered the correct start or end token respectively. So we want to get the start and end token positions from our output. So we'll create our start index and then use torch.argmax. And then from the output we can take the start logits. The same for our end index, we can take the output.end logits and again run this through torch.argmax. Let's then print the start index and end index so we can see which positions are the start token and the end token. So we'll see the answer in our text starts at token 20 and will end at token 23. So let's use this to pull the correct tokens and get our response. We want to create our answer, and then we'll join together the tokens between the start index and the end index position plus 1. We can then print this out and we can see our answer is March 24, 1997. If you remember, we fed the model the question, when was the first DVD released? And our answer document contained the answer, March 24, 1997. So our BERT model has worked here, it's found the correct response in our answer document. Let's visualize the different tokens and their probability of being selected as the start or end token. We're going to create some charts, so we're going to want to import matplotlib as PLT and import Seaborn as SNS. We then want to find the scores for each token, pull them out of PyTorch tensors and convert them to NumPy arrays. So for our start scores, we want to take the outputs, the start logits, detach them, run NumPy and then flatten them to convert these into a NumPy array. The same for our end scores. We'll be using the tokens as x-axis labels. In order to do that, they all need to be unique. So we'll add the token index to the end of each one of them. So we want our token labels as a list, and then for I token and enumerate tokens, we take the token labels and append the index to the end of them. This will make each token unique for our axis labels. Next, let's create a bar plot showing the start word score for all of the tokens. SNS.barplot, and X will be our token labels, and Y will be our start scores. We then want to turn the X-axis labels vertical, so we want to set X tick labels and set the rotation to 90. We'll also turn on the vertical grid to help align the words to their scores. Now we have this chart, you can see the probability of each word being selected as the start token. We can see the model considered a few different options, but in the end it was correct at identifying March as the correct start word for the response. We can then do the same for our end tokens so we can see the different options the model considered of where to end the response. And again, we can see it considered a few options, but it was pretty clear that it knew that 1997 was the end of the answer to the question we were asking. You should hopefully now have a better understanding of how the BERT model ingests and processes data